Okay, so we all get how solar panels work, right? They grab the sun's heat and light to make electricity. But what if we could do the complete opposite? What if we could actually generate power from the cold, from the dark? I know, it sounds like something straight out of sci-fi, but this is a real technology, and it's totally flipping the script on how we think about renewable energy.
That's a quote from an electrical engineer, Aaswath Raman. And just think about that for a second. Imagine driving through a place so completely dark that you don't even realize people live there. That single, really powerful experience, well, that's exactly where this whole story kicks off. So, how does a moment of just total darkness spark a massive technological breakthrough? Let's dive into the drive that started this whole thing. So, picture this. Dr. Rahman is in Sierra Leone. This is back in 2013. He's driving through this village, and it is pitch black. He can't see a thing, but he can hear the voices of people all around him. And in that moment, he didn't just see a problem, a lack of electricity. He saw the darkness itself as a resource, a massive, totally untapped source of energy just waiting.
And that led to this really radical question that's at the core of everything. I mean, we're so used to looking up at the sun for power, but what if we looked up at the night sky, at that huge, cold, empty space, and asked, could we harvest that? It's a total paradigm shift.
Okay, so to even begin to answer a question like that, you have to understand this really fundamental process. It's something that happens all around us, every single night, and it's the absolute key to how this whole thing works.
It's called radiative cooling. And look, everything, you, me, the chair you're sitting on, is constantly giving off heat. During the day, it's no big deal because the sun is pumping way more heat in than is going out. But at night, especially on a clear night with no clouds to act like a cozy blanket, that heat just radiates straight out into the freezing cold of deep space. You've actually seen this. You know when you see frost on the grass in the morning, even if the air temperature never dropped to freezing? That's because the grass literally got colder than the air around it. It beamed its heat away into space. And I love this analogy. Think of a clear night sky as a giant portal to the void. It's just this huge opening where warmth can escape. So Dr. Raman's big idea was, well, what if we could stick something in that portal to grab a little bit of that energy as it's rushing out?
And you know what's wild? This isn't some newfangled physics concept. Humans have known about this for thousands of years. I'm talking 6,000 years ago, ancient Persians were building these amazing beehive-looking things called yakshals to make ice in the middle of the desert, using this exact same principle. So the idea is ancient. What's brand new, like 2019 new, is figuring out how to take that effect and actually generate electricity with it. Okay, so the theory is solid. But what does a device that actually harnesses the cold of space, what does it even look like?
You'd probably be surprised. It's super simple, almost kind of low-tech looking. The first prototype that proved this whole thing was even possible, it basically looks like a hockey puck sitting inside one of those chafing dishes you see at a buffet line. Seriously. It's up on these little legs so air can get all around it. But, of course, inside that simple little package is where the real magic is.
So here's the breakdown. It's a 3-step dance. Step 1, that black disk on top, you point it at the night sky. It immediately starts beaming its heat away and gets colder than the air around it. Step 2, the bottom part of the device, it just stays at whatever the normal air temperature is. Step 3, you stick a totally standard thermoelectric generator, nothing fancy, right in between that cold top and that warmer bottom. And that small temperature difference, that's all you need. It gets electrons moving, and that, my friends, is an electrical current.
And the result? It's just perfect. That little bit of current was enough to power a single white LED light. I mean, think about it. Dr. Rahman took the very darkness that inspired him back in Sierra Leone and literally turned it into light. So we know it works. That's huge. But the next logical question is, how well does it work? I mean, powering one tiny LED is an amazing proof of concept for sure, but to really get a handle on what this technology can do, we need to talk numbers. So the prototype device cranked out about 25 milliwatts per square meter. Now, unless you're an electrical engineer, that number probably doesn't mean a whole lot. So let's put it side by side with, the daytime champ, a solar panel. And yeah, here's the big reality check. A regular solar panel, on a good day, it's pumping out around 200 watts per square meter. This device, it's giving us about 0.025 watts. That's not even in the same ballpark. It is a massive, massive difference. And the reason is pretty simple, right? A solar panel is tapping into the gigantic temperature difference between the super hot sun and us here on Earth.
This little guy is working with a temperature difference of just a few degrees. So let's be clear, this is not going to replace solar farms, not by a long shot. But, and this is a huge but, comparing it that way kind of misses the whole point. This isn't trying to be a solar panel. It's a completely different way of thinking about energy. For one, the materials are dirt cheap. One expert literally called it a piece of metal with spray paint on it. There are no moving parts, so it's super durable. And here's the kicker. It works when solar panels don't, at night, and you don't need expensive, complicated batteries. It's not about raw power. It's about accessibility and rock-solid reliability.
And this quote from physics professor Ellen Williams just hits the nail on the head. She points out that because it's so inexpensive and durable, it could be a game changer for the developing world, the very places that sparked the idea in the first place.
So if this isn't about powering entire cities, then what's the future look like? Where does this cool little technology fit in?
It's all about finding the right job for the right tool. Think about it. Powering remote sensors out in the middle of nowhere that have to run day and night. Or giving a family in a remote village a few hours of light to read by. What about street lamps in places where climbing up a pole to replace a dead battery is a huge pain? It's not a replacement for solar. It's the perfect partner, the night shift, that takes over when the sun clocks out.
And this is just the beginning. This research is actually kicking open the door to a whole new field that scientists are calling dual-use thermotics. The idea is to create devices that could do both, soak up solar power all day, and then flip a switch and use radiative cooling to generate power all night. The best of both worlds.
And that leads to one last, really mind-bending idea. Okay, so if this technology is basically a heat valve for planet Earth, a way to let extra warmth escape into space, what if we could build it on a massive scale? What if we could actually aim that energy? Could we use this to help cool our own planet, while at the same time beaming all that waste heat towards, say, Mars to help warm it up? Look, it's a wild, far future idea for sure, but it just goes to show you what can happen when someone looks at total darkness and sees not an absence, but an opportunity.